Okay, is that screen visible to everyone?
Yes, sir, it is.
Okay, thank you very much. So today, actually, I have your second hour and fourth hour class, but I will take this second and third hour class continuously. And the fourth hour class will be taken by Sosikant sir. Okay, so please attend those class also. And so let me class to start the syllabus. So before proceeding to the new topics, last class we discussed about till now, whatever we discussed, let me briefly give a recap of it. So what we discuss is we start with the introduction of heat transfer, that is what is temperature, its units, dimensions, and what is heat and what do you mean by heat transfer. Then we go for the modes of heat transfer, in which we discuss conduction, convection, and radiation. The basic introduction of conduction, convection, and radiation we discuss. Basic introduction means what? What do you mean by those things? What is conduction, what is convection, and what is radiation? On which mode of heat that is transfer, then we call as that conduction. Okay, if it is transferring due to molecular movement, that we call the convection mode of heat transfer. If through the vacuum or through the electromagnetic wave, then we call it as a radiation mode of heat transfer. If the heat is transferred due to this molecular vibrations, that we call as conduction heat of a mode of heat transfer. Generally, we prefer conduction in heat and this convection in case of fluid and radiation in case of vacuum or space. Generally, this is the general. But the actual definition is when the heat is transferred due to the molecular movement, sorry, molecular vibration, that is called conduction. When the heat is transferred due to molecular movement, that is in the fluids, that is called convection. When through the electromagnetic wave or through the space or vacuum, that mode of heat transfer is called convection. Then what we discussed, okay, what is our objective of heat transfer? Our objective of heat transfer is to calculate the rate of heat transfer. We know that when there will be a temperature difference between the two objects or 2 points, then there will be heat flow will occur from higher temperature object to a lower temperature object. Certain energy will flow. That energy we call it as heat. But our objective in this heat transfer is to calculate the rate of heat transfer, or you can say speed of heat transfer. So how to calculate? So the three modes are there. So for the three modes, three laws are there. For conduction, okay, let me share you. Yeah. For conduction, we have Fourier's law of heat conduction. Okay. That what is defined? It is defined the rate of heat transfer means the amount of heat, speed of heat transfer due to conduction is directly proportional to area of heat transfer that is taken perpendicular to the direction of heat flow. If the heat flow is in this direction, then this area will be our heat transfer area. Okay, always it will be perpendicular to the direction of heat flow and temperature gradient. Okay. This is the area of heat transfer and temperature gradient. Temperature gradient dT by dx. In case of Newton's law, convection, we use Newton's law of cooling or Newton's law of convection. What it defines? The rate of heat transfer is directly proportional to area of heat transfer and temperature difference between the high temperature object and low temperature object. According to then radiation law, what is that radiation law? Stephen-Boltzmann's law. According to it, the rate of heat transfer is directly proportional to area of heat transfer and temperature to the power fourth. Temperature means what? That high temperature body will be there, na? That temperature to the power fourth. Then we use the three proportionality constant. What are the three proportionality constant? For conduction, we use small k, that is that for thermal conductivity. For convection, we use small h, that is heat transfer coefficient. And for radiation, we use sigma, that is Stephen-Boltzmann's constant. Its units are also very much important. K watt per meter Kelvin, H watt per meter square into Kelvin, Stephen-Boltzmann's constant watt per meter square into Kelvin to the power fourth, because T to the power fourth is there. Okay. How you determine? Q is equal to sigma A T to the power fourth. We have to find the unit of sigma. So Q, we know that what? Area is meter square, Kelvin fourth, sigma. And what is the unit of sigma? Watt per meter square, Kelvin fourth. These things we discuss. Okay. So these may be asked for a 10 marks question. What do you mean by conduction, convection, radiation, and their difference? In which mode of heat transfer, in which mode the heat transfer rate will be higher? Can anyone say? On conduction, convection,
Sir,
or
radiation in conduction, the heat transfer rate will be high, sir.
okay. Conduction, convection, radiation. Okay. So my question is, in which mode Q will be higher? Okay. In which mode Q will be higher? So Jeevan, he gave the answer. It is conduction. Anyone have any other answer? The question is on which mode the rate of heat transfer will be higher, conduction, convection, or radiation? Yes, Bari, are you listening?
Conduction, sir.
Conduction, yeah, roll number 8. It's you are also telling conduction. 2 votes I got for conduction. Any other answer? Yes, Bari.
Sir, radiation, I
Yes, sir.
think.
Radiation.
Conduction.
Okay. Bari is conduction. One person say radiation. Who is that?
Number
Sir,
28, sir.
one doubt, sir.
Okay, 28. Okay. Yes, Jeevan.
Sir, one small doubt, sir. Before the answer, before I
Yes.
share the answer, uh, radiation in the sense in the speed of electromagnetic waves, sir.
Yeah, through wave it will go.
So it will be in the speed of electromagnetic wave only,
Yes.
and then radiation only is faster. Speed
So
of light
last,
is the fastest
yeah,
known speed, no, sir.
yeah. Last class also the same thing I discussed. I think may have forgotten. So we are discussing, the question is on which mode of heat transfer the rate of heat transfer will be higher. Simple question. Either it is conduction or convection or radiation. Okay. We have to find Q, in which case it is higher. So you find in in 3 cases area is there. Okay, it is same. So this K, H and sigma, these are the proportionality constants. So let us leave it. So then we go for the third term is delta T by del X. Here delta T is there. Here temperature to the power fourth is there. So here Q is directly depend on delta T by X. Here Q is directly depend on delta T. Here Q is directly depend on T to the power fourth. So according to mathematics, on which you can find the Q is more? Obviously T to the power fourth is there. So
T to the
radiation
power
it
4
will
is
be.
more.
So through radiation, the rate of heat transfer will be always higher than conduction and convection. Then again come to conduction and convection. Here we find Q is directly proportional to delta T. But here you find Q is directly proportional delta T by del X. By is there. By means what? Something reduced. Okay, suppose here 5 is there. Here 5 by 2 is there. Which one is greater? 5 is always greater because here some by is there.
5 is greater.
So Q will be Q through convection is always greater than Q is equal to convection. So Q radiation, then Q convection, then Q conduction. Okay, these are the rate of heat transfer through different mode. This we discuss according to that formula. So practically, if you assume, so conduction, how the heat will transfer? Generally, the solids molecules are tightly packed in conduction. Then how the heat will transfer due to molecular vibration? Okay, so this will how the it will go from this point to this point. Here, in fluids or convection, these molecules are freely movable. So these solids can be move freely from this point to this point at very less speed. Is it audible?
Now we are
Yes,
we are able
sir.
to hear it, sir.
Okay. Okay, thank you. So what you observe is, here you can see here the heat will travel due to the molecular vibration or this atomic lattice vibration. So the resistance will be more, or we can say to travel from this place to this place, it will take more time. But in case of fluids, the resistance will be less. Why? Because the molecules are freely movable. How the heat will transfer? Through the molecule. So this molecule may travel from this direction to this direction, this direction to this direction. It can travel freely. The hot molecules or cold molecules. So the resistance will be less. In case of vacuum or space, how much resistance will be there? No resistance. The example is there. Suppose say you have to send a letter to your friend, okay, who is in some Delhi or somewhere else. So suppose say you will send it by some person, okay, or a 4 to 5 person will be there, deal with them. So what will they? You will give this letter to one person, that person will give to another person, then that person will give to third person, like your speed post or postal system. Okay, that how it will go, that post is coming. Like that, heat will also come in contact with these molecules. Because in the solids, the heat can't be moved freely. So it will take more time. So more resistance will be there. But in case of fluids, it is like your courier system. Okay, how they will flow? So they will flow in the flights. Okay, so directly or through less contact. In the courier system, what will they find? Through the less stoppage that will reach to you. So the resistance is less. So the the heat can be traveled more freely. Then the no resistance. No resistance will say the mail system, or you can say the WhatsApp messages, in which what you do, you can send directly to one person to another person. There is nothing in between. So the message can go quickly. So this is the difference. Like you can relate these things to this practical examples. Okay, I just gave an example. So till now you must be clear that there will be more resistance in case of heat to transfer because of the molecular arrangement, less resistance in the case of convection due to the freely available of molecular transfer, and more heat transfer in case of radiation because there will be no resistance. Okay. Okay. So next, this is all about this conduction, convection, and radiation. Now we'll discuss about only conduction. Okay, that's unit 1. From now, it is all about conduction only. Okay, this is the basics. So from now onward, the unit 1 is only related to conduction. Conduction means what? Heat is transferred due to the molecular vibration or lattice vibration. The transfer of heat due to the lattice vibration without motion of molecule, and generally in the case of solids. So yeah. So what is the formula for conduction? We use Fourier's law of conduction. Okay. What is the Fourier's law of conduction? We know the rate of heat transfer through the conduction is directly proportional to area of heat transfer taken perpendicular to the direction of heat flow and temperature gradient. or you can say the Q is equal to minus Ka dt by dx. Okay, here K is the proportionality constant. To remove these proportionality things, and minus sign why we are using, because if you take the delta x positive, then delta t will be negative. If delta x will be positive, then we'll have delta t negative. So, and the overall Q will be negative. But that is not practically correct. So that's why to make the formula practically correct, we are using a negative sign. Okay. So this is all about Fourier's law of heat conduction, where Q is joules per second, rate of heat transfer per unit time, or you can say watt, where area is meter square, or dt by del x is Kelvin per meter, where K is what? Thermal conductivity. What's its unit? Watt per meter Kelvin. Okay, this is what we discussed till now on conduction. Then let us discuss more about thermal conductivity. Okay, I told you this is the most important topics. So let's discuss more about thermal conductivity. So before going into thermal conductivity, let me ask a simple question. Suppose say you two persons, suppose say I have one metal rod, because we are discussing conduction. So we'll take example of solid materials. So this is suppose say silver, or suppose say not silver, iron. Let us take iron. Or let us take one copper, one iron, one wood, and one cement. Okay, let us take these solids. All are solids because we are discussing about conduction. Let us take the example of four solids. Both have equal size. Okay, both have equal area and equal volume. They all have same area and same volume. Okay, so then what we'll do? We apply heat in this area. In this area, how will heat apply? Suppose say we put a heater at 200 degrees centigrade. Suppose say in everywhere, all the example, we put a heater at 200 degrees centigrade. What is its initial temperature? The initial temperature, let us say 30 degrees centigrade, room temperature. Okay, initially it is at 30 degrees centigrade. Then what we did is we put the heat source at the other end. Okay, so my question is, suppose say you four persons are there, person 1, person 2, person 3, person 4. You are holding this other end. You all people are holding this other end. So my question is, in which case you will find, you will feel the heat. You will feel the heat at less time. You will feel the heat at less time.
Sir, copper.
Iron.
So, the question is,
Copper, iron.
you understand this area, this end is at higher temperature, 200 degrees centigrade. Okay,
Yes,
this
sir.
end is at room temperature. You are holding this
Yes, sir.
temperature. So at on which person will feel the heat? Heat means what? High temperature at less time.
High temperature. Person 1 and person 2, sir.
Person 1 and 2 feel heat at less time. Okay, very good.
Very less time.
Okay, but my question is, these are all solid materials.
Yes, sir.
How the heat will transfer from one point to this point? Through conduction only.
Yes, sir.
Okay. Till now it's clear. In
Yes,
all
sir, it
this
is.
matter, the heat will transfer from this point to this person through conduction only. So what is our formula? Q is equal to minus Ka dt by dx.
Delta T by delta.
This is the conduction. So we are interested in finding Q. Okay, the rate of heat transfer, feels heat at less time means what? If the rate of heat transfer is more, means the temperature will rise morely. If Q will be more, then we'll feel the heat will be more at this temperature. Yes or no? If rate of heat transfer
Yes,
is more, then we will feel heat at less time. So Q we have to find out. So in all these cases, area is same.
But nature
Yes
of
or
the
no?
material is different, na, sir.
Yeah. Let us discuss according to our law. Nature of material is different thing. This is our law, na? This is the proposed law for area of heat flow. Okay. So area, both the case is different, same. We are finding this is a one law, Fourier's law of heat conduction. This scientist, he gave that this law, that if the solids the heat will transfer, then heat will transfer according to this formula. So let us check the validity of this formula. So we take the example of 4 solids which have same area, same volume. So we are calculating, we just give same temperature difference, and we are calculating why in copper, iron and iron the heat will transfer at more rapidly compared to 3 and 4. That's what we are discussing. The area, all the case it is same. What is the delta T? Delta T is nothing but temperature difference, 200 minus 30. All the case it is same. What is delta X?
The
Delta X
delta
is
T
the
is 30
length.
minus 200, na, sir.
Yeah, 30 minus 200 you can take, sorry. Final minus initial. Okay, 30 minus 200. So delta X, suppose say it is 0 centimeter, you are 10 centimeter. Then delta X will be 10 minus 0. Okay, delta X is also. So you can see Q. In the formula of Q, area, delta T, delta X for all the 4 components is same. Then what is the thing that will different so that the Q will different? What is the extra thing is there for which the Q is different for all the materials, because area is same, delta T is same, delta X is same. And what is the thing for which the Q is different for all the things? That answer is K. Okay, or you can say thermal conductivity. The thermal conductivity value for copper, for iron, for wood, and for cement. This thermal conductivity value for all these materials are different. For thermal conductivity material, for copper is higher, then iron is less, then wood is much less, and cement is much less. So in which case, so you can find in both 4 cases, area same, delta T is same, delta Q is same. So K for this one is more. So you will find Q is more here. K for cement is less, so you will find less heat transfer. So what will define more rapidly for the rate of heat transfer in conduction? That most important thing is thermal conductivity. And the thermal conductivity is defined according to the nature of object or material. Okay, in some material or solids, the thermal conductivity will be higher, and some material, the thermal conductivity will be lower. So if thermal conductivity is higher means what? The heat transfer will be, okay, let us discuss this.
Very fast.
Yeah, if Q is equal to, we defined K A dt by dx. Okay, so we know that area delta T delta X will be same. So if thermal conductivity is of a material is high, of a material, if the K value is higher, then what will find? The Q value will be also higher. K value will be higher means Q value will be higher. Then what we can say? We can say it is a good conductor or carrier of heat. If K value is what? It is a property of material. If the K value is less, then what will happen? Q value will be also less because it is directly proportional. If value of K is less means what you can say? Lower rate of heat transfer, or you can say it is a good insulator of heat. Okay. So next, let us find, you know about, if the K value is more, we can say it as a good conductor of heat. If K value is less, we call it good insulator
A good
of
insulator of it.
heat. So the conductivity or is depend on the K value. That is called thermal conductivity. So let us discuss some examples. So some of the best conductor of heat. Best conductor of heat means what? Through this medium, the rate of heat transfer will be higher. Okay,
Very
the
high.
first examples are silver ornaments you are using, copper wire you see, okay, gold, aluminium. These material will have higher thermal conductivity of heat. It means what? If you heat at this end, this material, the temperature will reach at very higher speed to other end. Or you can say the thermal conductivity is higher. Why? The K value of this material is higher. Okay. Then in opposite, what is thermal insulator? Where the K value is less. How much less? Around 0.2 watt per meter Kelvin. The examples are asbestos, glass wool, cork, etc. So in your home, nowadays you may not find, but you go to some village area, you may find that uh, they will use either tin, asbestos, or now we are using a cemented one. Okay. Okay, the top of our home, you may find these three types of. If you go to some village area, they will have this type of top structure in the top of their house. But if you go to town area, we have cement type of structure. What is the difference? Why that thing is there? The cost is different thing. Okay, but according to, let us discuss according to the heat transfer rate. So we have a sun. Okay, so we have to get the protect from the heat from the sun. So cement, the K value is less. Then according to come to tin and asbestos, these are of low cost. Okay, so not everyone can be affordable. So many people use either tin or asbestos. So tin is highly, according to strength wise, the tin or steel one, these are highly strength wise. Okay, but if you consider the heat wise, the asbestos between the tin and asbestos, okay, the asbestos will give less heat transfer. Less heat transfer. That's why most of the people who use, almost the strength is less, but they use to get the less heat from the sun to inside the home. Okay, so they are using asbestos. Why? Because the heat transfer rate will be less. Why that? Because that material's K is less. Glass wool. Where we are using glass wool, can anyone see? In case of furnaces. Okay, if you see, we are using the glass wools. Okay, corks, everything that industrial you are using for the to provide the less heat transfer. Okay, so let us discuss then. Okay, what is the unit of K? Okay, unit and dimension. Although I discuss again, let me discuss again. What is the unit of K? Q is equal to Ka dt by dx. What will the unit of K? How to determine
Watt
what?
per meter Kelvin.
Meter square Kelvin by meter. Okay, K. So it will be meter cancel out. So it will be watt per meter Kelvin. Okay. So next is what is the dimension of K. So how to determine? So we have the formula watt per meter Kelvin. So let us write one by one. So meter. What is for meter? What is the dimension? This meter.
L.
L. Capital L. For Kelvin, capital T.
It is
Okay.
T.
For temperature T. For watt. What will be the
For watt,
dimension? Watt is stands for watt. Joule per
joule per second.
second. 1 joule is equal to, we know, it is the source of energy. So
Newton.
Newton into meter by second. So what is Newton then? Mass into
Mass
acceleration.
into length.
So mass into acceleration
Yes, sir.
into meter. Meter is length, time is theta. So we can write this mass into acceleration. Mass means capital M, acceleration means L into theta square
Theta minus
into L.
L by theta.
Acceleration means what? Meter per second square. Okay.
Yes, sir. Yes, sir.
Acceleration by theta. So what we'll get? It is meter L square theta minus 3. Okay. It is per watt. So the dimension of K will be M L square theta 3 minus Q by L into T. So it will be M L theta minus Q T inverse. Okay. This is the dimension of
K.
okay, some technical error was there. So now I think it's clear. Okay, so next is how to define the K value. Okay, what is the definition of K? So first thing is, it is what? It is the proportionality constant. Proportionality constant in which law? It is the proportionality constant in Fourier's law
Fourier's
of
law
heat conduction.
of heat conduction.
Fourier's law of heat conduction. Okay, thank you. Fourier's law of heat conduction. Okay, it is the first definition. Another what is now? K means it is the according to the nature of heat conduction. It is the
Nature of the material.
not nature of the material. It is a property of material. It is the property of material that defines heat conduction. Heat conduction rate. Okay, these two definition it is clear. First thing it is a proportionality constant in Fourier's law of heat conduction, basic definition. Then what is defined? It is the property of material that defines the heat conduction rate. So another definition is there. What is the third definition? Okay, according to formula we go. So we can you write Q is equal to Ka dt by dx, or we can write K is equal to Q by area into dt by dx. Okay, we can write this one. Suppose say now area is equal to 1 meter square. Okay, delta x is equal to 1 meter and delta T is equal to 1 Kelvin. Suppose say these three things we take, assume it. Area is equal to, we take 1 meter square area, 1 meter length, and delta T 1 Kelvin, difference temperature 1 Kelvin. And what will be the value of Q? K? K will be Q. Yes or no? If you take the area as 1 meter square, let us consider delta X means the length of the material is 1 meter. Delta T means the temperature difference between the two things is 1 Kelvin. Then what will be the value of K? This is 1, 1, 1. So K will be Q. So this is the third definition. So the third definition is like this. You can say, read here. Thermal conductivity is defined as the rate of heat transfer through the medium by conduction. It means what? K is equal to Q, as I discussed right now. Thermal conductivity is what? Thermal conductivity means it is the rate of heat transfer through the medium by conduction. Simple definition. When having unit area, unit thickness, and having unit temperature difference. When area is equal to 1, delta T is equal to 1, and delta X is equal to 1 meter. Then what is the rate of heat transfer? That is called thermal conductivity value. Okay. So this is all about the thermal conductivity. Okay. So next goes to some values, some thermal conductivity value. So thermal conductivity is always depends on temperature. Kindly remember. Thermal conductivity is the function of temperature. Generally, the K value, this is a simple table to understand. So for your syllabus, it may not require, but for some competitive examination or in interviews, they ask this question related to these tables. Okay, so kindly look into it. So the table is like that. It is the value of thermal conductivity. Okay, and how it is depends on temperature. Thermal conductivity, how it depends on temperature. So let us discuss for three materials: solid, liquid, and gas. So K value for solids, it will be generally higher. Thermal conductivity value for solid material, it will be generally higher. Okay. Thermal conductivity for solid material, it will be generally higher. How much? The solid means for metals. It will be in the range of 10 to 400 watt per meter Kelvin. Please remember this range. In most of the interview or in competitive exam, they will have this type of question. For solids, the conductivity in the range of 10 to 400 watt per meter Kelvin, and it will be generally higher compared to liquid and gases. Then for liquids, or you can say non-metals, it will be between 0.2 to 1 watt per meter Kelvin, the range of thermal conductivity. And for gas, it is much lower, 0.01 to 0.1. Okay, and in solids, if you increase the temperature, the thermal conductivity value will be reduced. If you decrease the temperature, the thermal conductivity value will be increased. But one exception is there. What is that? Uranium. In uranium, if you increase the temperature, the thermal conductivity will also increase. This is all about solid. In solid, the K value will be generally higher. It is range between 10 to 400, and the temperature and K value is inversely proportional. It means what? K for the metal, if will increase, temperature of the metal, if will increase, the K value will decrease, but except uranium. Uranium is a solids. Next come to liquid. Liquid, generally the K value is below. It is from 0.1 to 1. Yeah, just let me finish. So
Okay.
here also same. The temperature if will increase, the K value will also decrease, except for water. If you increase the temperature, K value will increase. If you decrease the temperature, K value will decrease, directly proportional. But all other liquids, it is inversely proportional. In solids, for uranium, it is directly proportional. For all other material, it is inversely proportional. Next, come to gases. For gases, the temperature and thermal conductivity is directly proportional. If K is increased means temperature increase means thermal conductivity increase. Temperature decrease means thermal conductivity of gas will decrease. Okay. So this is the basic things. Next, let us discuss some increasing order. Generally, in the multiple choice question, they will give 4 components. Okay, in which case the thermal conductivity is higher. Okay, so this is one type of tables. So you can say gas. Gas means what? It is in the range of 0.2 to 0.1. It will be lower. Then water and ice. This is generally in the liquid. So they will have between 0.1 to 1. Then we have copper. It's having 390. Then aluminum, low carbon, and these are all are solids material. Okay. This is comes under liquid and this is comes under gases. So solids material will have always higher thermal conductivity than liquid than gas. Okay. So if any multiple choice question type, this will become always the thermal conductivity of solids will be higher. In solids also they have different. I told you now, it is in the range of 10 to 400. It is in the range of K value 10 to 400. So coppers it will be 300. It may be 200. Low carbon steel may be 100. Bricks may be 80. Like that it may be there. This is just a probable values. Okay. So next is that so till now we discuss the K value is the function of temperature. It means what? With respect to temperature, the thermal conductivity value is changing. So how it will changing? So exact formula, many scientists after so many of research, they found out it is defined as K0 into 1 plus alpha T plus beta T square. Okay, just let me check. Yeah. So after so many of this K value, thermal conductivity value is depends on temperature. Okay, how it is depends. So after so many scientists found the numerical relation. What is the numerical relation? The thermal conductivity is directly proportional equal to K0 into 1 plus alpha T into beta T square. So this is what the relationship between thermal conductivity. We know the thermal conductivity is a function of temperature, but how? The equation is this one, where what is K? K is equal to thermal conductivity at any temperature, at any temperature T. Suppose say at any temperature T, suppose say we have one metal is there. Okay, we have to find the thermal conductivity value at 300 degrees centigrade, at 200 degrees centigrade, at 100 degrees centigrade. What will be the value of thermal conductivity? It will change. It will have some X value, it will have some Y value, it will have some Z value. Why? Because we know that thermal conductivity is the function of temperature. If the temperature is changing means thermal conductivity will changing. So what is the value according to that temperature? So that formula is this one, where K0 is equal to thermal conductivity at 0 degrees Celsius. The thermal conductivity of that material at 0 degrees centigrade. What is that value? That value is called K0. Okay. Alpha and beta, these are the proportionality constant. These are the constants, depends on materials. Depends on materials. Okay. So this is the relationship between K and temperature. So let us solve a simple numerical. Okay, I will just give a simple numerical based on this formula. So all of you, I think you can read this question. Yeah. A plain wall of metal. Okay, please read it the question. A plain wall of metal having thermal conductivity 10 watt per meter square at 0 Kelvin, 0 degree centigrade, and coefficient of thermal conductivity is 0.8. Calculate the thermal conductivity of material at 0 degree centigrade. Okay, so what is it is given? Okay, so it is first is given, it is a plain wall. Okay, next, its thermal plast is plain wall. Plain wall metal, it means what? Conduction, because it is a solid material. Its thermal conductivity is 10 at 0 degree centigrade. It means what? Thermal conductivity at 0 degree centigrade, it is 10 watt per meter Kelvin, or you can say K0 value it is given. Then what is asked? The thermal conductivity at 30 degree centigrade. Thermal conductivity at 30 degree centigrade is how much? So what is the temperature? The temperature is 30 plus 273, or you can say 303 Kelvin. Why? Because K we are representing now watt per meter Kelvin. So we have to represent the temperature in the Kelvin scale. Okay. So what is the formula? The formula we know K is equal to K at 30 degree centigrade, or you can say 303 Kelvin is equal to K at 273 Kelvin, or you can say 0 degree centigrade into 1 plus alpha T plus beta T square. Okay, let me write here. So we know the formula K at 303 Kelvin is equal to how much? K at 0 degree centigrade or 273 Kelvin into 1 plus alpha T plus beta T square. Where, okay, this is the formula. So what is the K at 2007 degree centigrade or 0 degree centigrade? It is 10 watt per meter Kelvin into 1 plus. What is temperature? Temperature is 300 degree Kelvin. 300, 30 degree centigrade na? 30 degree centigrade means 303 Kelvin plus beta into T square, 303 square. This is the formula. Okay, but there is certain correction is there. So in case of plain wall, the beta will be generally 0. Just remember. In case of plain wall, the beta value will be 0. So what we can say? We can eliminate this one because beta will be 0. So what will be the K value at 30 degree centigrade? It will be 10 into 1 plus alpha. What is the value of alpha? This alpha is nothing but coefficient of thermal conductivity or 0.8. 0.8 into 303. Same thing. 10 into 1 plus 0.3. Okay, this is 0.8. Some intake mistake is there. This will be 0.8. Okay. So whatever the value will be there, that will get. Okay. So this is the value. How we'll do if the value of thermal conductivity of 0 degree centigrade is given, then we can find out the value of K at any temperature. K at 30 degree, K at 300 degree centigrade, K at 200 degree centigrade by using this formula. Okay. So yes, any doubt till now? Jivan, you have some question?
Yes, sir. One small doubt, sir.
Yes.
Sir, when we are discussing about thermal conductivity when it comes to solids, gases, and liquids,
Hmm.
that property is my doubt is that
Yes.
when heat is increased, the thermal conductivity will decrease. It will not, sir.
Yes, sir. For solids and
Uh,
liquids.
Yes, sir. But in case of solids, sir, heat increase so like in the source area or overall body, sir.
The delta in the source, just a minute. In the overall
Source
body,
point
you
or
can say
overall body
delta T.
temperature.
Yeah, delta T you can say.
Okay, so overall body temperature increases, then conductivity will decrease.
Yeah.
Decrease, sir.
Yeah.
Okay, okay.
But in
So like
gases, the temperature will increase, then thermal conductivity will also increase.
increase.
You can ask me the question why.
Sir, when heat is increased, motion of the molecule is also increased because high energy, so it gets mixed faster. So conductivity can also increase that way.
But what I told that will be for solid and liquid, it is inversely proportional, except for uranium and water.
Yes, sir.
For gases, if temperature increase means the thermal conductivity will also increase. Why that is things?
Yes, sir. Because in gas, molecules are even more free than what liquids, no, sir.
Yeah.
So when energy is given, the molecules are excited, so they move very faster than normal.
Yes.
So in that case, when heat is given, the mixing rate is also very fast.
Okay.
So naturally, the conductivity is also increased.
Okay. Then why in case of solid and liquid it is decreasing?
So in case of solid, it is tightly packed, sir. So it is only by vibration.
So vibration means we are discussing conduction will be na. More conduction
Yes,
it
sir.
will go.
I didn't get you, sir. When it comes to solid?
Yes. If conduction means through vibration only it will go.
Yes, sir.
So for solid and liquid, there should be more vibration. So more heat transfer will be there. So why with increasing temperature, the K value decreasing?
Sir, when temperature difference is very less, the speed will also
Okay.
decrease.
Yeah, that example is there. So you ask the genuine question. Okay. So many books you will not find this answer. So most of if you go to some very good institution for interview, they will accept this type of the answer from you. They will ask this type of question. Okay, why? First thing is what is the mode of conduction? Due to the in conduction molecular due to molecular vibration only. Yes or no?
Yes, sir. Molecular vibration.
So now you think if you increase the temperature of a object, suppose say solid, ice, liquid, gas, how it is changing after changing the temperature only? Yes or no? Ice to
Yes, sir.
liquid or gas. So
Yes,
what is happening to their molecular distances? Molecular distance I am telling about. With
Yes, sir. It is
temperature,
increasing.
with increasing. So in solids also, suppose say a solid at less temperature, a solid at high temperature will be there. In which case the distance will be more. Both are solid only. In which case the distance will be more.
At high temperature,
The distance will be more. So here, so now you see here vibration, same vibration will be there. In which case vibration will transfer more rapidly.
in low temperature region.
Low temperature because the molecules are tightly packed. Okay, but
Yes,
here
sir.
the molecules have some distance. So even if this molecule is vibrating, this molecule will feel less vibration. That's why the difference, the temperature is inversely proportional to K for solids and liquids. But in case of gases, what happened if you increase the temperature, the kinetic energy will increase. The kinetic energy increase means what? The more bombard between the molecules will occur. More bombard means what? There will be more contact between the molecules. So more contacts means more heat transfer. Okay. So I think most of you, did you understand, Jivan?
Yes, sir. I understood, sir.
Okay, I think most of you may not understand this concept, but for them it may not required. But if you go for higher studies, some research, these concepts will be highly beneficial. Otherwise, just remember, for solid and liquid, if temperature we are increasing, thermal conductivity will decrease. For gases, if the temperature is increased, thermal conductivity will decrease, except for uranium in case of solid and water in case of liquid. Okay, so it's around 11:30. So let me take the attendance, download the attendance sheet. So as I mentioned that I will take the next hour also. So in the next hour, what we'll discuss is we'll discuss very important 10 marks question. Very, very, very important 10 marks question. Not very important, very, 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 very important 10 marks question. If you understand this 10 marks question, another 2 marks question you can relate. Okay. If you understand this 10 marks question answer, then another 10 marks question is there in unit 1 answer only. So this is the basic understanding. So kindly do attend and try to understand. Very simple concept, derivation is there. We'll do it. So if you understand these things, another 2 long questions will be there. That will be having same format. As per the same format, it will go. Okay. So in the next 1 hour, we'll discuss the first concept. The next 2 concept is as per this concept, similar to this concept. Okay. So you can also derive the same. So it is very much important, all of you, to understand this 10 marks question. I know that many of you are not listening to this class, but please do listen to the next class. Okay. So I will just close the class right now. So I will give you a 5-minute gap. So at 11:35 we will meet again and we will start. Okay, take a 5-minute break. So 11:35 again we will start the class. Okay, but I will be online. If you have any doubt, any question, then you can ask me. But I will start the class at exactly 11:35. Okay, thank you. You can leave the class and join the next class.